Start with the risk, the left side of that ratio.
The risk is crucial because it's the only variable you can completely control. It's not your total investment, it's the maximum loss you are prepared to accept on that single trade. For a trader, this is the distance between your entry point and your stop loss level.
That parachute, as some people call it.
Precisely. It's your parachute and you secure it before you jump. So if you buy stock at $100 and you decide your stop loss is going to be at $98, your defined risk is $2 per share.
Okay, so that's the one in our 1 to 3 example. Now, the reward.
The reward is the potential profit, defined by the distance between your entry point and your take profit level. Following that same example, if you expect the stock to reach $106, your expected reward is $6 per share. Now, if you look at those numbers, a $2 risk and a $6 reward, that's a ratio of 2 to 6, which simplifies perfectly to 1 to 3.
That's a huge shift in philosophy. Instead of asking, how much will I gain, the professional asks, how much am I willing to lose first?
Absolutely. And here's the magic. Most beginner investors think they need to win 50% or more just to break even. But think about our 1 to 3 scenario. Because every time you win 3 times what you lose when you're wrong. You only need to be right 25% of the time to be profitable over the long run.
25%. That changes the whole game. You're essentially telling the market, I'm okay with losing 3 out of 4 times, as long as the one time I win pays for all those small losses and then some.
That's the statistical edge, and that's the real magic that leads to something called positive expectancy.
Strategic fusion. Positive expectancy and the casino's edge. Positive expectancy. That sounds very professional, but what does it mean in plain English?
In simple terms, it's the average value you expect to gain or lose per trade over the long run. It's the formula that proves your strategy is financially sustainable. You have to ensure that your winning trades, multiplied by their probability, outweigh your losing trades, multiplied by their probability.
Give us an analogy to make that stick.
Think about a casino. The casino doesn't win every hand of blackjack or every spin of the roulette wheel. People walk out winners all the time, but the casino only needs to maintain a slight positive expectancy, the house advantage, in every game. Over the long run, the mathematics guarantee the casino's profitability.